Example 1. Well, I hope you can see that we have, we've got a minus 3y in this equation and a plus 3y in this equation. So the easiest thing for us to do is simply to add the equations 1 and 2. That will give us 3x plus 2x is 5x. Minus 3y plus 3y is 0. 12 plus 8 is 20. If I divide by 5, x is 20 over 5, and then x equals 4. What I want to do is to substitute that back into one of the equations, either equation 1 or equation 2. So 3 lots of x, 3 lots of 4, minus 3y equals 12. 3 times 4 is 12. Subtract 12 from both sides. Lo and behold, we've got minus 3y equals 0 and y equals 0. That's a perfectly good solution. So x equals 4 and y equals 0. Example 2, just a little bit more complicated. I hope it's still reasonably obvious that we're going to eliminate y. We have plus 6y in this equation, and we've got minus 2y in this equation. Now, we can only eliminate y if we have the same number of y in both equations, so what I'm going to do then is to multiply equation 2 by 3. Equation 1 will remain unchanged, so 2x plus 6y equals 36. This is equation 1 unchanged. Equation 2 times 3, 3 times 3x is 9x. 3 times minus 2y is minus 6y. 3 times minus 1 is minus 3. Now, we have the same number of y in both equations. One is positive and one is negative. What am I going to do then? I can now add both equations together. So 2x plus 9x is 11x. 6x plus minus 6y is 0. That's what we intended. 36 plus minus 3 is 33. And x then is 33 divided by 11, which gives us the answer 3. What we have to do now is to substitute this back into one of the equations. I'm going to use equation 1 because there are no negatives. And that will allow us to find the value of y. So 2 lots of 3, 2 lots of x, plus 6y equals 36. 6 plus 6y equals 36. Subtract 6 from both sides, we've got 6y equals 30, and then y equals 5. So the solution to this set of equations is x equals 3 and y equals 5. Example 3, the equation is starting to get a little bit more difficult. Which of the two, the x or the y, are we going to eliminate? It doesn't really matter. In example 2, we had to multiply one of the equations so that the y's were equal, although different in sign. What we can now do is, well, I'm going to choose to eliminate the x. Now, in order to do so, I must have the same number of x in both equations. What I can do is multiply this equation by 7, so that this 2 will become a 14. And I can multiply this equation by 2, so that 7 becomes a 14. So, equation 1 multiplied by 2, that gives us 14x plus 8y equals 72. Equation 2 by 7, 14x plus 6y, I beg your pardon, 14x, 7 times 3 is 21, and 7 times 14, 7 tens are 70, and 7 fours are 28, So the answer is 98. Now, you can see that we've got a 14x here and a 14x here. Unlike the two previous examples, these are both plus 14x. Now, so there's no point in us adding the two equations together. That would give us 14 plus 14, which is 28. We're supposed to be eliminating x, remember? So what I'm going to do then is to subtract. Now, there's a reason for me subtracting in the order 2 take away 1. Wonder whether you can see what that is. 14 take away 14 is 0. 21. 21y take away 8y is 13y. 98 take away 72 is 26. Divide by 13 and we get the answer y equals 2. I'm going to substitute that back into equation 1. Now I think I'll use this equation 1 here. That's the first of the two equations. So 7 times x plus 4 times y, 4 times 2 equals 36. 7x plus 8. Subtract 8 from both sides. 7x equals 28, and x then has the value 4. So the solution is that x equals 4 and y equals 2. Fourth and final example. The two equations are just a little bit unusual looking. If we look at equation 1, you've got the x, the y and the number term all on the same side. So what I'm going to do here I think is probably just move the minus 5 across. How will I do that? By adding 5 to both sides. Plus 5 plus 5. So 2x plus y equals 5. Here's my new equation 1. In equation 2, you'll notice that I have the x on its own and the 4y on the right hand side. So what I'm going to do then is just to subtract 4y from both sides so that the x and y are on the same side. And we can now proceed. So the main purpose of example 4, the main point, is that sometimes we have to rearrange the equations initially before we can proceed. What I'm going to do now, I don't know whether you can spot, I'm going to eliminate the y term, and I'll do that by multiplying. I'm going to multiply equation 1 by 4. So what does that give me? 4 times 2x is 8x plus 4y equals 20. Equation 2 is unchanged. You'll notice we've got now 4y and a minus 4y. So how do I deal with that? I'm simply going to add the two equations together. 8x plus 3x is 11x. 4y plus minus 4y is 0. 20 plus 13 is 33. Divide by 11 and we get x equals 3. Substitute that back into equation, well, which equation will I use? I think I'll use this equation here. Into equation 1 then. So 2 lots of x, 2 lots of 3, plus y equals 5, 6 plus y equals 5. If I subtract 6 from both sides, I have y equals minus 1. So the solution is that x equals 3 and that y equals minus 1.